This is a Boston housing data which is available from the sklearn dataset. First, we need to import some libraries such as NumPy, Pandas, Matplotlib, and this library is used to plot the graphs. And to import Boston housing data, we need to have sklearn dataset imported into our project, and this has been successfully done. And now we are moving to step 1, data preprocessing, importing the data. Here the Boston variable has been loaded with the Boston dataset and it has been printed. .cdescr is abbreviated as descriptive. Next, we have to put the data in the pandas data frame. To print the feature column, we are giving features. It has 13 features. This is called as the features, and these are the values. And to get a specified feature, we can use this function to store the target column to the other data frame called target. And here we use target variable to store the data. To find the maximum value, this function is being used. To find the minimum value, this function is being used. Now let's come to concatenation. We can also concatenate the features and target. Axis is equal to 1 denotes the column-wise concatenation. We can also use the describe data frame object to which the count, median, standard deviation, minimum value, and percentiles and maximum value has been found. And step 2, data visualization. Now we have to find the correlation value between the target and the feature, and the correlation has been calculated, and ABS stands for absolute, and to make the list of pairs, and it has been sorted, and the k and lambda function has been used, and the function which has been zipped here has been unzipped, and it has been plotted into a bar graph. And this is the bar graph. See, the values have been plotted accordingly. And step 3, normalization of data. And the data has been normalized. This is the values before normalization, and we are using the min-max scaler to create an instance. And after creating an instance, the data has been printed here. And splitting of the data into equal sets. The data has to be splitted into equal sets, and 80% of the data is used for training and the 20% is used for testing. And let's come to mean square error, and there are 3 functions. They are error, update, and gradient descent. And this is the error function, and the equation, this error function, update, and gradient, these 3 have an equation, and this is the equation. And let's come to update, and this is update, and the equation has been performed. And this is the gradient. Here the for loop iterations takes place, and init_m, init_c, and learning rate has been initialized. And finally the regression curve has been plotted, and the B stands for blue color, and red, and R stands for red. And this is the error graph. The error has been decreased. This shows here. And visualization of model. And here the animation takes place. This function is imported here. It is imported here, and a video kind of thing. to calculate the predicted values, predicted is equal to m into x test plus c. This equation is used. By using this, we can calculate the mean squared error, and the output is here. And pd.data frame list zip x test comma y test comma predicted columns is equal to x target y predicted y, and these have been printed here, x target y and predicted, and the graph has been successfully plotted. And here, reshape the array and revert normalization. Here reshape function is used, and scalar function to get rid of the